Hello, and welcome. This video will explain how to solve this question using the TI-84. It says to construct a binomial probability distribution table using n equals 5 and p equals 0.21. Next, record the mean and standard deviation of the distribution below. Where necessary, round all numbers to 4 decimal places. Let's talk about this for a moment. It says that we have a binomial probability. That means that we only have two outcomes. We have either success or failure. We are running this experiment 5 times, so n is 5, and x is the number of successes. Whatever that means in the question, we don't have a defined success here, so we're just dealing with that. So we have a couple different options we could have. We could have 0 successes and 5 failures, 1 success and 4 failures, 2 success and 3 failures, 3 success and 4 failures, 1 failure, no, 2 failures, we can't count, 4 successes and 1 failure, or 5 successes and 0 failures. Sorry about that, I'm just getting over a little head cold. All right, so from here, we can plug in those x values. Oh, what am I doing? Oh my goodness. 2, 3, 4, and 5. There we go. Now I've got this figured out. All right, so in the TI calculator, let me just clear what I got here. We'll come back to this in a second. If we hit Stat, hit Enter on Edit, we'll open up our lists. We're going to put our x values into L1. And then in our L2, we're going to put our probabilities. Now our probabilities are going to be based off of the binomial probability. So in the TI calculator, we could use the distribution, press second vars, distribution. We can go either up or down to A, which is binom PDF. We have 5 trials. Our p-value is 0.21, and our x value is 0. Press paste, hit enter, and we'll get that the probability is 0.30771. And then we can go through the same process again, second distribution. There's a fast way of doing this by pressing alpha and math, which brings up the letter A. Make sure it's binom PDF. Change this to an x value of 1, because the table now is in the row for 1, which is 0.40898. Then we can press second distribution again, alpha math, change the x value to 2, press enter. We get 0.21743. Oops, wrong button. Second distribution. Oh, I think I messed this up. No, there we go. Second distribution, alpha math, change the x value to 3. Sorry about that. I covered my microphone. Hopefully that wasn't too loud. I will pause the video next time if I have to cough. 0.0578. And we're just going to keep doing this for the last two. Second distribution, alpha math, change the x value to 4, hit enter. 0.00768. And then second distribution. I guess I could have just done this all along. This is why I was using the alpha math, to avoid scrolling all the way down. X value is 5, hit enter. And now we have some scientific notation. So 4.1e negative 4 is a calculator's way of showing scientific notation. So this just means that we need to move the decimal place 4 places smaller. So 0.0004. Technically 4.1. All right, so now we have our distribution entered into our calculator. We can calculate the mean and standard deviation. When we're dealing with a binomial probability, the mean and standard deviation are always calculated as population values. So we'll hit Stat, go to Calc, 1-bar stats. Our list, our X values were in L1. Our frequency list is really a probability list, but our list is now in L2. So press second 2, go down to calculate, press enter, and we get that the mean is 1.05. You'll see that there is no sample standard deviation, because as I was just mentioning, we always deal with population values when we're dealing with a binomial probability distribution like this. And the standard deviation, sigma, is 0.91. So we found the mean and standard deviation. If you've been following along with the class notes, you know that there is also a way of finding the mean and standard deviation using formulas. The mean can be found with the formula n times p, which just means we could do 5 times the probability of 0.21, which again would give us 1.05. And the standard deviation is the square root of n times p times q, where q is 1 minus p, or the complement. If the probability of success is 0.21, then the probability of failure is 0.79. And I'm not even going to worry about calculating that, because I can just type all of this right in. I just use second and the x squared button to bring up the square root. 5 times 0.21 times parentheses 1 minus 0.21. I'm just going to let the calculator do it all for me. And we'll get the same standard deviation, 0.910. Alright, thanks for watching.